we want to determine the following four limits that involve the greatest integer function. Our function is f of x equals the greatest integer of the quantity x plus 1. This function returns the greatest integer that is less than or equal to the quantity x plus 1. Let's take a look at a table of values. Let's consider the function values for these given x values. Notice when x equals 1, we'd have the greatest integer of 2, which does return the function value 2, since 2 is the greatest integer less than or equal to 2. And this corresponds to this point here on our function. So notice all the function values stay at 2 through here until we reach an x value of positive 2, and then the function value jumps to 3. So going back to our table of values, notice how for 1.2, 1.4, 1.6, and 1.8, the function values remain at 2. For example, for x equals 1.2, we have the greatest integer of 1.2 plus 1, or 2.2. The greatest integer of 2.2 is 2, since 2 is the greatest integer that is less than or equal to 2.2. So it isn't until we reach an x value of 2 that the function value jumps to 3, as we see here. And the function value stays at 3 until x reaches a value of 3, then the function value jumps to 4, and so on. This is also often called the step function, and you can see why. So going back to our limits, we first want to determine the limit as x approaches 1.2 of our greatest integer function. Well, x equals 1.2 would be somewhere in here. And notice as we approach 1.2 from the positive side or right side, and as we approach 1.2 from the left side or negative side, we are approaching the function value of positive 2. This first limit is equal to 2. Next, we have the limit as x approaches 3 of our greatest integer function. X equals 3 is here. Notice in this case, as we approach positive 3 from the right side or positive side, the function value is positive 4. But as we approach from the left side or negative side, the function value is positive 3. Since these one-sided limits are not equal to each other, this limit does not exist. The last two examples are one-sided limits. Notice in both cases we're approaching 2, but this limit here is from the positive side or right side, and this last limit is approaching from the left side or negative side. Here's where x equals 2. So we'll first approach 2 from the positive side, which would be from this direction, and notice how the function value would be approaching positive 3. It's not only approaching positive 3, it is positive 3 all along here. And then finally, as we approach positive 2 from the negative side or left side, the function value is approaching positive 2, or once again is positive 2 as we approach from the left. And therefore this one-sided limit is equal to positive 2. I hope you found these four examples helpful.